Hello. In this video I am going to show how to create a racetrack in the Trackmania mesh modeler. In order to do this I open a map in the main editor, in this case a 128 cube day grass base map. I recommend to use such large base maps made by Ibo. The way the Trackmania editor typically works is that you place blocks of track next to each other. However, with the mesh modeler, you have the ability to form an entire track or section of a track out of a single item. To begin, we need a block that we can deform. For this demonstration, I've selected a simplified version of the Road Tech Vanilla block. After placing it, open it with Edit Selected Item. This opens the item editor. From here, click on the tool symbol adjacent to Mesh to access the Mesh Modeler. In the Mesh Modeler, the first step is to navigate to the Layers menu. By default, new items are assigned a geometry layer. Within a geometry layer, you can directly edit the faces, edges, and vertices of an item. In the case of our block, its entire geometry is contained within this geometry layer. However, to deform the geometry, we need to add an additional deformation layer. To do this, I simply click on Add New Layer, which opens a window presenting various layer options. There are essentially two main types of layers, the three types at the top, which can be modified by the 9 layers at the bottom, with the exception of the spawn position layer for waypoints, which neither modifies the upper layers nor is it modifiable by the bottom layers. After adding a deformation layer, we now have 2 layers in total. To edit the deformation layer, simply click on the tool symbol associated with it. Here's how this layer works. The editor calculates a spline by following control frames that you can manipulate. As you adjust these control frames, the item will deform along the spline, allowing you to sculpt and shape it according to your preferences. There are 5 options for editing the deformation. Number 1. Selecting the origin of the spline. This option is only applicable when there is only one control frame. The origin of the spline defines where it starts. To select the origin, click on the orange dot representing the current origin. You'll enter origin selection mode, where 4 clickable orange dots, one on each side of the geometry, will appear. Choose the origin by clicking on one of these orange dots. Number 2. Adding a new control frame. Click on the green dot located at the end of the spline to add a new control frame. Once selected, you can move it along the 3 axes. It's beneficial to set a specific tool step to create the new control frame precisely where desired. You can set an intermediate step by clicking with the right mouse button and then move from there on another axis. You can add the new control frame by left-clicking. As you can see, the item follows the spline. Number 3. Editing an existing control frame. Click on the yellow dot at the center of the control frame you wish to edit. This enters the control frame edit mode. Here, you'll notice 4 yellow dots. The central yellow dot allows you to adjust the position of the control frame. Click and hold it with the left mouse button and move it along the 3 axes. Again, you can set intermediate steps by right-clicking. The yellow dot at the side enables you to change the orientation of the control frame, thus creating a turn. Click and hold the dot, then drag it along the circle. This adjustment works in steps of 5 degrees. When the orientation reaches 90 degrees, the circle turns blue, serving as a helpful indicator. The yellow dot at the top corner allows you to adjust the banking. This also works in steps of 5 degrees. The yellow dot at the top edge enables you to adjust the slope. Again, the step size is 5 degrees. Number 4. Inserting new control frames between existing control frames. To enter this mode, click on the yellow button between 2 existing control frames on the spline. This will reveal 11 equally distributed yellow dots to choose from between the existing control frames. Select one by clicking on it to create a new control frame at that position. The new control frame will adjust its orientation, banking, and slope between the neighboring control frames proportionally to its position between them. Note that this method allows us to create angles with less than 5 degrees precision, what isn't possible otherwise. Number 5. Deleting an existing control frame. Simply right-click on the central yellow dot of the control frame you wish to remove. This option is only available when there are at least 2 control frames present. After editing the deformation, we can return to the geometry layer to make further adjustments there. Here's how the interaction between the geometry and deformation layers works. The geometry is automatically replicated along the spline of the deformation, meaning any changes made to the geometry will be applied uniformly along the entire spline. For instance, if you extrude one face of the geometry, the change will be replicated along the entire spline. To better understand this process, let's demonstrate by rotating the geometry. which will most likely have an unusable result. As you can see, the deformation is applied to an imaginary box surrounding the geometry. The box encompasses the geometry's highest, lowest, leftmost, rightmost, closest, and farthest points. Therefore, to ensure a seamless racetrack, it's essential that the start and end points of the geometry align on the x and y axes, while being shifted on the z-axis. However, variations between the start and end points of the geometry, such as the extruded face demonstrated here, are perfectly feasible without issue. An excellent aspect of the deformation method is its flexibility. It can be utilized with any geometry, giving you the freedom to diverge from the predefined forms of standard blocks and instead craft designs limited only by your imagination. Next, I'll demonstrate how to craft a unique road geometry from scratch, ready to be deformed later on. I begin by selecting Item Mode and then Create a new item. From there, I click on Mesh. Every new item initiates with a standard cube in a geometry layer. While we can utilize the top side of the standard cube as a foundation by removing all other sides, we also have the option to start from a completely blank slate. To initiate the creation of the first face, I access the creation tools specifically designed for generating geometry from scratch. I select Create Face and adjust the tool step to 1 meter. Moving along the axis, I left-click to establish the first vertex. Continuing, each subsequent left-click generates a new vertex and forms an edge between it and the previous one. Utilizing right-click allows me to set intermediate steps for movement along another axis. After creating the fourth vertex, I complete the face by double-clicking on the first vertex. At times, a face may be oriented in the wrong direction. Fortunately, you can easily rectify this by selecting the face and pressing I to invert it. It's important to note that faces are only visible and collidable from one side, which is all we need for a racetrack. The initial face I've created will serve as the middle line of the track. A width of 0.25 meters is ideal for the middle line. I suggest starting from the center of the track and then gradually moving outwards with new faces. Next, I'll craft a second face to represent one lane of the track, with a width of 4 meters. Then, I'll create a third face to serve as the outer line of the track, with a width of 0.25 meters. Following that, I'll generate a face for the hard shoulder, with a suitable width of 3 meters. Now, I'll allocate 4 meters for a grass area. I will apply the material later. Now, I'll add a 0.5 meter wide foundation for a wall, which I'll later extrude from the face. Finally, I add some more grass faces beside the track. Another crucial tool is the Move tool in Essentials. With this tool, I'm able to select a face, edge, or vertex and adjust its position. I'll utilize this tool to design the edge of the track with a gradual slope. Next, I'll proceed to apply materials to the geometry. Navigating to the Materials section, I'll find numerous pages of materials available for application to selected faces. For this instance, I'll opt for custom concrete currently to be found on page 16. Choosing a darker gray color, I'll select the faces intended to represent the road and apply the material accordingly. I apply custom grass to the faces that are supposed to be grass. For the face that will be a wall I use a white concrete. For the sideline of the track I also use white concrete. The next set of useful tools are the copy and paste tools found within the modeling tools. The modeling tools are made for modifying already existing geometries. I proceed by selecting the entire geometry and setting the tool step to 1 meter. Then, I utilize the copy and paste functions to duplicate the selected geometry. To connect the two geometries, it's important not to paste the copied geometry directly onto the correct location. doing so won't establish a connection between the geometries. Instead, they only connect when vertices are moved onto the same position. Working within a single geometry helps minimize shadow bugs and allows for easy variations to be made. I repeat this process several times, allowing the item to extend to the desired length, in this case 32 meters. The next handy tool is the mirror tool. Suppose I want to mirror one side of the track, excluding the middle line. I can achieve this by first selecting just the middle line and pressing Ctrl-I to invert the selection, thus selecting everything else except what was previously selected. When selecting faces, switching to material mode can be helpful, as only surfaces are selectable there, and no edges or vertices. After selecting the middle line while holding Ctrl, I invert the selection, return to the modeling tools, and mirror the selection. With the tool step set to 0.25, I then move the mirrored part to the other side to connect the sections. Returning to the materials section, I apply white concrete to one half of the middle line, creating a dashed appearance. Another useful tool for creating walls is the extrude selection tool found in the modeling tools. Setting the tool step to 1.125 meters, which is a suitable height for a wall, I select the wall faces and extrude them on one side of the track. I recommend deleting the end plates of the wall, as they can potentially cause landing and shadow bugs, and they serve no practical purpose. Faces can be deleted by selecting them and pressing the delete key or by pressing X and clicking on them. In this example, I only want the wall to be on one side of the track. That's why I mirrored the track first. Otherwise, it would have been better to extrude the wall before mirroring. I'll now replace the concrete with grass on the other side. The last step is to move the geometry by half the width of the middle line which wasn't mirrored towards the center, to centralize the item what can be important later on. Now this geometry example is finished. Now that we've covered the general functionality of using the deformation and geometry layers, I'll address some common issues with the deformation tool. Understanding these problems and how to handle them is essential as they can impact our overall approach to creating racetracks. Later on, I'll discuss some approaches to constructing a complete track. Number 1. Uneditable control frames when reopening a deformation layer. For some reason when reopening a deformation layer the form of the control frames depends on the angle of the last control frame relative to the z-axis of the item. When the angle is 90 degrees the form will be compressed to in line with limited usability. This does only happen when reloading the spline, so creating such an angle does not cause the problem directly, but when reopening the deformation layer. So if the control frames look like this it is caused by a 90 degrees angle of the last control frame relative to the origin. It can be solved by adding a new control frame, shifting it to the side, inserting a new control frame between the new one and the last one and then deleting the last control frame. Now the inserted control frame is the last with a different angle. We now have to close and reopen the deformation layer, and the form of the control frames will be usable again, and we can delete the inserted control frame. Number 2. The question of how to create turns with a clean consistent radius. While it is a straightforward thing to create a 90-degree turn in a continuous radius by moving the control frame forward and sidewards by the size of that radius, a bit more math is needed to create continuous turns for other angles. I recommend to use a spreadsheet program and to use the following formulas. First of all, convert the angle from degree into radian by dividing it by 180 and multiplying it with pi. The formula for the forward shift is the radius times the sine of the angle in radian. The formula for the sidewards shift is the radius times in brackets 1 minus the cosine of the angle in radian. You can often round the results to meters without a problem. Simply applying these formulas to the position of a new control frame works without a problem for angles between 60 degrees and 120 degrees, but below and above additional problems occur. When you create a small angle turn below 60 degrees you can notice that the actual turn will be tighter than expected. The exact form of such small angle turns also depends on the length of the deformation. The easiest attempt to fix this is to move or to delete adjacent control frames. This can often solve the problem, but the exact form of the turn gets less controllable. Another possible attempt to solve this is to divide the deformation into smaller items, because the form of small angle turns is usually better with smaller items. Start a new item at the location you want the small angle turn to be. Create the turn and continue the deformation. You can notice that the form of the turn changes when you continue the spline, from too wide to correct to too tight. You can create the correct turn form by continuing the deformation to the right extent, and use again a new item from there on. You can exactly connect the items by using translation layers to position them. Angles above 120 degrees also have a problematic form. But this is easy solvable by just combining two medium-sized turns. For a 150 degrees turn you can use for example simply two 75 degrees turns. By the way, for all the turns I always calculate the right construction numbers with the formula. Number 3, how to make smooth banking transitions. Different bankings can often lead to little bumps when using the deformation tool. This has two different reasons. For both reasons things can be done to create a smoother banking. The first reason has to do with the position of the pivot point of the banking rotation. It is exactly located in the calculated center of the item. The editor calculates the highest and lowest as well as the leftmost and rightmost points of the geometry and calculates the middle point of these extreme values. This often means that the pivot point of the banking is below the racing surface, but it depends on the geometry you use. However, we can manipulate this calculation without actually changing the effective racetrack geometry. Just copy a face beside the track in the yellow mode and place it way above the geometry. Scale it down to a very tiny size and use a surface without shadows like glass or even better an entirely uncollidable surface. Now the center of the banking rotation is above the track, what creates smoother banking transitions. But there is no right or wrong pivot point of the banking, it depends on your preferences. Note that the section with the higher banking now is rather turned to the side instead of just slightly upwards. This already smoothens the banking. The second and more important reason for bumpy banking transitions is the flat nature of its application. The editor doesn't apply the banking change in a smooth sine type curve but just in a flat line. But we can manually create a smooth sine-like transition by inserting control frames between the start and the end of the banking transition and shifting them towards the middle to the position their respective bankings would have in a sine-type curve. But we need a formula for this shift. The formula is the arc cosine of in brackets 1 minus 2 times the position on the transition brackets closed divided by pi minus the position on the transition. Before shifting a control frame, I create the complete amount I want to have. Important are especially those close to the beginning and end of the transition. So first I insert a control frame at the middle of the transitions at 50%, then to both sides again, one at the middle at 1/4 and 3/4, now again towards the side a pair at 1/8 and 7/8, another pair at 1/16 and 15/16 and a last pair at 1/32 and 31/32. The central control frame does not need to be shifted. The result of the formula for the four pairs from inside to outside are 8.3%, 10.5%, 9.8% and 8.2% of the transition lengths. All shifts have to be done towards the middle. This partition creates already a smooth sine curve-like transition, but you can do this with even more control frames if you want. Just calculate the needed shift with the formula. Number 4. Late geometry changes extending the previous extrain values. The editor stores the deformation relative to the imaginary box around the geometry. So by expanding or reducing this imaginary box, the deformation changes. To prevent this, you can either make only changes inside the current extents of the geometry or use a little surface to extend the box as shown before creating the deformation. Number 5. Another characteristic of the deformation tool is that changes of the direction banking or slope of the last control frame also change the way new control frames are created. This can complicate later adjustments to multiple control frames, as they may have different orientations. Additionally, this means that slopes and bankings can be converted into each other when making turns. For example, when I add some banking to the last control frame and then add a new control frame in a 90 degrees turn, the new control frame will have a corresponding slope instead of banking. This results in flat racing surfaces, but it can be confusing if you are not aware of this. So keep it in mind. If you don't want this interaction, it is a solution to just add the banking after the control frames are created, so the following control frames are not affected. Number 6. Another thing to know is that applying a deformation somewhat compresses the geometry. At the position of control frames the geometry will be exactly the right one, but not in between. This is irrelevant for most use cases, but it can be a problem for specific cases like partitioning a geometry after a deformation. It is just something to keep in mind. Now with these things mentioned, I want to suggest 6 methods to actually create a complete racetrack. Number 1. The complete track in one item. We can just use a deformation layer within one item until the complete track is done. This is probably the easiest method, and it has some advantages and disadvantages. Advantages are: one advantage is the flexibility to use various combinations of slopes, bankings, and direction changes without needing to worry about understanding the precise mathematical orientation of the spline. This is particularly useful because bankings can transform into slopes during turns, making the mathematical orientation complex. However, with this method, since the deformed item doesn't need to be connected to another one afterwards, such complexities are not a concern. Another advantage is the ability to easily apply additional modifying layers to the item, such as scale layers or rotation layers. These layers can help refine the track further, such as scaling down the track's height if there are too extreme jumps for the speed. Advantageous is also that later geometry changes can be applied to the entire track effortlessly. Disadvantages are: one disadvantage is that small angles cannot be executed perfectly. Another potential drawback is an editor lag when the item becomes too large. This may require limiting the overall length of the track or simplifying the geometry, depending on the capabilities of the computer. Editing the deformation later can also be limited. For instance, adding a 90 degrees turn in the middle of the route will not rotate the following parts of the track by 90 degrees. While minor adjustments like widening a turn are possible, significant changes may be challenging. Finally, a complete track in one item cannot be reused for a different track. Reusability is only possible with item sets. An example of a track where I use this method is Mountain Road 10. The entire track was made in one item. A technique which I used extensively on this track was the transformation of bankings into slopes, because creating small angles is problematic with this method as mentioned before. For example, the slope of the start section was created by transforming a banking of a previous straight which was hidden by the scenery. Number 2, medium-sized items. Similar to the first method, we deform the item, but instead of completing the entire track in one item, we finish the item after a few turns and place a new item at the appropriate angle where the old one ended. In the new item, we add a translation layer to position it precisely, followed by a deformation layer to continue the track. Items can be rotated by 15 degrees in the main editor, so let the items end in an angle relative to the item orientation that is a multiple of 15 degrees. Advantages are: this method allows for better construction of small angle turns. The overall length of the track is less limited since smaller deformations do not lag while editing. It provides greater flexibility for making changes later, such as adding a 90 degrees turn, because the following items can just be placed somewhere else with a different rotation. Another advantage is that with each item different geometries can be used to make very different types of sections. Disadvantages are: Additional effort is required to precisely place the items with transition layers. Changing the geometry later requires additional effort since the changes have to be made to all items. Applying modifying layers like scaling or rotation is more complex if not impossible if you want to maintain a coherent racetrack. Care must be taken to ensure understandable orientations of the spline to be able to cleanly place new items at the end of the previous one, limiting wild combinations of bankings, slopes, and non-right angle turns. Like the results of the first method, these items are also likely not reusable for different tracks unless you want to copy complete sections. An example of a track where I use this method is Landstrasse 7. The track is composed out of medium-sized items. One thing I did on this track was to use different geometry layers for the visible and for the collidable geometry. The collidable geometry is also composed out of different materials with unique surface physics. But this is a topic for an independent video. Another track where I use this method is grass track. On this track I mirrored one side of the track with a separate mirror layer. This allows for easier later adjustments like moving the fence to a different place, because it only has to be done on one side of the track and gets automatically mirrored. Number 3, the third method is similar to the second, but instead of adding one control frame after the other at the end of the spline until an item is finished, we place the final control frame first. Then we insert control frames between the beginning and end of the spline. This approach can lead to unique and natural turns and combinations, though it may require some experimentation to understand fully and to avoid bad spline interpretations by the editor. An example of a track where I use this method is Mountain Road 14. The track features unique speed tag turns. But the end of the track was a bit problematic. The method can be very tricky to use well. Number 4, using multiple deformation layers. One deformation layer can for example be used to create a smooth elevation profile across the span of multiple turns created with another layer. Notice that the slope at the middle of this 180 degrees turn is perfectly smooth when using this method. Another possibility is to make small turns with two different layers for a track with a very natural characteristic. I recommend to not use hard turns in the first deformation layer, because they can easily result in very weird turns if they get further deformed by additional layers. Advantages of this method are: one major advantage is its effectiveness in creating long slope changes over the span of multiple turns, as the challenge of creating small angles for slopes is minimized. It also allows for the creation of diverse combinations of turns, making it particularly useful for designing natural tracks like downhill tracks. Disadvantages are: editor lag may occur when using multiple deformation layers, but utilizing the deformation tool within the geometry itself can mitigate this. Maintaining an understandable end orientation of the item to connect it to the next can be challenging and prone to mistakes. Overall, this method shares similarities with the previous two methods but offers distinct advantages in certain scenarios. An example of a track where I use this method is downhill number 3. On this track I used no grip ice for the collidable geometry. As you can notice, the editor is laggy because of the complicated deformations and a suboptimal mesh. For the first deformation I used the geometry internal deformation tool. But one mistake I made was that I applied the initial deformation to a mesh with a length of just one face. The deformation tool places the deformed mesh just in place along the spline, but doesn't connect the meshes. The overlapping vertices just get placed on the same spot, but they do not get united. This means the file size is bigger, what can result in lags in the editor. But it also increases the probability of shadow bugs at each overlap, and can create shadow bug nightmares. So as mentioned early in this video, it is better to unite the meshes yourself by moving the vertices on top of each other in the yellow mode and to use a mesh with some length for deformations. Number 5, an item set on the grid. This method is quite different. We can use the deformation tool to create standardized reusable items. For this example I remove the wall, so I don't have to worry about mirrored versions for each item. I replace the dashed middle line for the same reason. I also place the item exactly in the center, so it can be placed better in the main editor. The first item will be a straight. I go to the item editor and to placement parameters and set the fly step to 8 and the grid horizontal size to the length of my item, in this case 32 meters. This defines the grid. I also create an icon for the editor and the first item is finished. I can create a turn item out of the straight item. I go to the mesh modeler and add a deformation layer. As an example, I want to make an 48 meters radius turn with 90 degrees angle. I shift the control frame by 48 meters to the front and to the side, and then remove the 32 meters of the straight length. Then I create the 90 degrees angle. I save the turn in the mesh modeler, then add an icon in the item editor, and save again, and the second item is finished. Now I take the straight again and make a chicane. Again I add an deformation layer and move the control frame by 2 times the length of the item to the front and by the length to the side. I add an icon and save the item. Now I shift the control frame to the other side to make also a chicane to the other side. By the way, in the item editor it is important to add the icon before saving the first time, otherwise the mesh can be deleted because of a bug. Now our little item set is finished, and I can create a track with it. You can create much larger sized item sets with this method, for example including items with elevation changes, bankings and slopes. This obviously adds difficulty to the creation process. Advantages of this method are: an advantage of this method is the reusability. Once you have an item set you can use it for multiple tracks and even upload it on Item Exchange for other mappers to use. Another advantage is that tracks are easy to edit. If you reuse the same items, the overall length of the track is also not limited because reused items don't add file size. Disadvantages are: a disadvantage is that late geometry changes would have to be applied to all items, which is impractical. Another disadvantage for item sets on the grid is that small angle turns don't exist at all besides chicanes. There is a complicated way to make specific 45 degrees turns, but this is advanced, and something like 15 or 30 degrees turns is practically undoable with items on the grid. Another disadvantage is that with standardized items, unusual combinations of slopes, bankings, and turns are difficult to make. Items of item sets tend to be less special to be reusable. An example of a track where I use this method is Board Track Challenge. The track is entirely made out of reusable items and features and unique scenery. Inspired by the glorious board tracks of the 1910s and 20s, I created high-banked wooden turns in a complex process. Number 6. An item set off-grid. The sixth and last method I suggest is to make an item set with items not on the grid but connected with pivot positions in the item editor. The idea is to make 15 degrees angle turns and use the plus and minus buttons in the main editor to rotate the items by 15 degrees, and to use snapping to connect the items. So let's create a 15-degree turn. The problem is that the deformation tool creates bad results when we just make a 15-degree turn. But what we can do is to make a 90-degree turn and then remove everything after the first 15-degree. But here comes the problem into play, that the deformation tool somewhat contracts the item, so we end up with something different than 15-degree. But there is a solution for this which I will show. First, we decide what radius we want to have. In this case, 100 meters. This item is currently 32 meters long. We calculate how long in meter a 90-degree turn with 100 meters radius would be. The result is 100 times pi divided by 2, which is equal to 157 meters. We divide the 157 by 6 because 15 degree fits 6 times into 90 degree. The result is about 26 meters. First, we have to scale the length of the item to roughly 26 meters. It does not have to be exact. In this case, I scale it to 80%, resulting in 25.6 meters. I do this so the item will fit 6 times into the 90-degree turn, which I will create now. I move the control frame 100 meters to the front, then I remove the 25.6 meters, and then I move it 100 meters to the side and turn it by 90 degree. Now I have a perfect 90-degree turn. Now I remove everything but the first roughly 15 degrees. But this turn is now only roughly 15 degrees because of the contraction. The solution to this is to remove the last section of the turn and to recreate it manually to end at exactly 15 degree. I select the edges at the front of the item and copy it, and calculate with the formula how much it has to be moved forwards and sidewards for 15 degree. In this case, 25.882 meters forward and 3.407 meters sideways. I paste the copied edges right there. Now I rotate it by 15 degrees. Now the edges are in exactly the right position. Now I have to create faces to actually use these edges. After all the faces are created, I give them the right materials and the geometry of the 15-degree turn is completed. Make sure that the start of the item is in the middle over the item position. This is necessary for the pivot position to work like intended. Now I have to make the pivot positions to make the item snapping. First I enter some placing parameters. Switch pivot manually is useful, but not necessary. I set the horizontal grid size to 0 to get the item off the grid and enable ghost mode. I set the pivot snap distance to a big number like 16. Now I add two pivot positions. The first one is right at 0, 0, 0. I set the second one to our calculated forward and sideways positions, in this case, Z to 25.882 and X to minus 3.407. I also add an icon. I save the item. Now when I place one of the items and hover with the mouse over it, it automatically snaps the next item into the right position. I can switch the pivot position by pressing Q and rotate the item by pressing the right mouse button for 90-degree rotations and plus and minus buttons for 15 degrees rotations. It fits perfectly. Now I also create a snappable straight. I make sure the item is placed in the same way over the item position as the 15-degree turn. The position is different compared to the on-grid item set. I set the placing parameters as before and add two pivot positions. This time the second pivot position will have a Z position at 32 meters and that's it. I add a symbol and save the item. Now I have also a snappable straight and our little off-grid item set is finished. Advantages of this method are: the biggest advantage of this method is that all kinds of angles can be created out of these 15 degrees angles, 15 degrees, 30 degrees, 45 degrees, 60 degrees and so on. As an item set, it is also reusable for multiple tracks. And the items also don't cost much file size compared to non-item set methods. Disadvantages are: a disadvantage is that these off-grid item sets are difficult to make. Especially if you want to add slope changes or banking to your items, it gets even more complicated. Another disadvantage is that tracks are not as easy to edit as with an item set on the grid because the items have extremely specific positions. You can redo a route, but it is better to be sure to make the right route directly before continuing the route. An example of a track where I use this method is NASCAR Challenge 7. The track is entirely made out of snappable items off-grid. We are now at the end of the video. I hope I was able to show you some mapping techniques to your liking. Good luck and have fun with it, and thanks for watching.